here's another example of solving when I have a square root in my problem. So first thing, it's not useful to square both sides unless the square root's by itself, but it looks like over here, the square root is the only thing on the right-hand side of the equation. And so I'm going to square both sides. Now the left I have to be particularly careful about in this example because notice this says x minus 5 squared. That means x minus 5 times itself. So sometimes when I see a whole quantity like that squared, I'll even just write x minus 5 times itself instead of writing squared, because it makes it much easier to remind me that I have to FOIL this. And so if I FOIL x times x is x squared, my inside-outside terms are both negative 5x, so that will combine to negative 10x. And my last term is negative 5 times negative 5 gives me positive 25. And over on the right, the squared cancels my square root. So now the square root's gone, but I notice I have a quadratic. There's a squared here, so I need everything on the same side. So I would say I'll move everything to the side with the squared. So I'll add 3x and subtract 43. Add 3x and subtract 43. If I do it on one side, I have to do it on both sides. So x squared, negative 10 and 3 is negative 7x, and 25 minus 43 is negative 18. And so now I could try to factor it since it's equal to 0. I think x minus 9 and x plus 2. And however much time you have to take guessing and checking to find something that multiplies to negative 18 and adds to negative 7. So that gives me two possible solutions here. I could have x equals 9 or negative 2. Now remember, in these type of problems, it's extremely crucial to check our answers because we can come out with answers by doing all the correct work that don't actually work in the original problem. The reason that happens is because when you square both sides, let's say you had a positive and a negative number, like 3 and negative 3 on each side. They're not equal, but if you squared them, it would cancel the negative. It would look like they were both equal. And so that's what causes that problem. But we should be in the habit of checking answers anyways. Good idea. So x equals 9 and x equals negative 2. So we'll put them both back in the original. So if I put 9 in the original, I get 9 minus 5 on the left, so that'd be 4. And then under the square root, I get 9 times negative 3, so that's negative 27 plus 43. So 43 and negative 27 gives me 16. So it looks like square root of 16 equals 4, so that solution works. All right, then we'll try our other one. So negative 2, if I put negative 2 on the left-hand side, negative 2 minus 5 would be negative 7. And on the right-hand side, I get negative 3 times negative 2, which would be positive 6 plus 43. And 6 and 43 gives me 49. And here's that positive negative thing I was talking about. See how square root of 49 is 7. This is close to working, but not quite, because 7 doesn't equal negative 7. But during our steps when we squared both sides, you could make it seem like they were equal, because if I square both sides, then it gets rid of the negative. 49 would equal 49. So this answer actually doesn't work, and so good thing we were checking them, because now we know our final solution is just x equals 9. The negative 2 was an extra, called extraneous, but it literally means an extra solution, one that doesn't work.